Hi everyone. Today we are going to do a very quick review about the median and the other statistics, and then we will move on to a new topic. We are going to talk about the dynamic set. Okay, so for the selection, the goal of the selection is we want to find the ice order statistics, and the definition of the order statistics is that assume that we have a list sorted from low to high, and then the order statistics with a specific number, for example, i's, and this means that the i's smallest number. And if we have all the values sorted, and then from the low to high, and then we just visit all the values, and then we stop at the index I, and that is the i's order statistics. Okay, and then to get the i's order statistics, one of the important things we want to remember is we want to go better than doing a sort. And when we do a sort, and then we are expected to spend n log n time. And the goal of the selection is we only want to get the i's order statistics. So we don't really care that all the values being sorted. So in this case, it's the best that we can get the i's order statistics without sorting all the values. And to do that, we borrow the idea of doing a partition. And for example, say if we have 2000 values, okay, so in this here we have a total of 2000 values, and then we were doing a partition. We are getting a random pivot, and say, well, for this queue, this is the pivot, and let's say this queue is after we do the partition, there are a total of 800 values here. So on the lower side of the pivot, we have a total of 800 values, and then we have one more value here, and then on this part we have 1199 values. Okay, so this is just a hypothetical case. And then since on this queue on the left side we have 800 values, and there's one thing we are guaranteed to know. So if we have all the values sorted, and then for this queue, this is definitely the 801st order statistics, right? Because there are 800 values lower than this value q. So for this value q, that is guaranteed to be the 801st order statistics. And let's say if we are interested in finding the 500 order statistics, and what are we going to do next? Or if we are searching for the 500th order statistics, which part shall we do the search? We want to do the search here, right? Because on the left side, we know there are 800 values. And those 800 values, they are all smaller than the pivot. If we are looking for the 500 order statistics, and then we definitely want to go to the lower side. So we only want to do a search here on the lower side. And another scenario is if you're looking for 1000 order statistics, and then you definitely want to go to the right side because there are 800 values here and then a pivot. So the 1000 order statistics will be on this side. So depending on the I, which is the order statistics you are looking for, after the partition, you only want to do a lookup or a recursive selection on one side, either the lower side or the upper side. Okay, so this is the idea of the randomized selection. So for the randomized selection, we are worrying about the worst case. So for the worst case, it's kind of similar to the worst case of the quicksort. We are worrying that when we are doing a partition, no value on one side, and all the remaining n-1 values are on the other side. And in this case, we are having the worst case. And for the worst case, we are having the tn equals the tn-1 because all the values are on the other side. And then for the partition, we have to the cost will be a on. In this case, we are doing a on square. But if we don't have the best case constantly, and let's assume that we are having bad partitions, 90% to 10% partition all the time. In this case, and we can still prove that this is a ON, so that is a linear time selection anyhow. Okay, so well, we will say even even we constantly have 90% to 10% partition, this partition is not really that bad, because for the selection problem, we can still achieve a ON algorithm, and ON is better than the sorting. So even in this case, 90% to 10%, we are still having a linear time selection, so not so bad. And later we also have a proof that we consider all the possible partitions, and then we expect the probability of different partitions to be equal, so the probability will be 1 divided by n. And then we did a similar proof to the average case of the quicksort, and then we are able to say for the average case of this randomized selection, and then we can say it is still a linear time, so it's not too bad. And then I introduced a really smart and really complicated algorithm for the worst case linear time selection. And I'm not challenging you guys to code this, or I code this in the homework or in the exam. So this is more like a in-depth discussion on a really smart algorithm. If I just skip this topic, and then I find that this is not a good course for a graduate level. Okay, and the idea is we want to get the median of the medians of 5 tuple. Okay, for a big data set, we want to divide this data set into 5 tuples. So for each tuple, we have 5 elements, and then inside of each 5 tuple or a group, and we want to get the median. And then we put all the medians together. So all the white nodes, they are the medians, and then we want to get the median of the medians, and then we call this value x. Okay, and after that we want to lay out all the values in this way. And what we want to highlight is, well, if there is an edge between one node to another node, this means this value is going to be larger than the value this edge goes into. Okay, and then if you see all the nodes on the shaded area, they can go to x directly or indirectly. This means for all those values, they are greater or equal to x. Okay, and then if you go here on the upper left corner, those are all the values that x can go to directly or indirectly. What does this mean? This means for all the values on the upper left corner, those are the values smaller or equal to x. Okay, and then we come back to the partition idea. Well, for each of the partition, well, as long as we find the pivot, and then we can use the x as a pivot, and then we know one thing: there are at least roughly 1/3 of the values greater than x. There are at least another one third of the values they are guaranteed to be smaller or equal to x. So depending on where the I goes, and by the way, I is for the i's order statistics we are looking for. Okay, depending on where the I goes, we can throw away either the higher 1/3 of the values or the lower 1/3 of the values. So every round, it's guaranteed that we can throw away at least 1/3 or 1/4 of the values we are searching for. So in this case, well, we are emphasizing on this part. So we can either throw away the lower right corner of the values or the upper left corner of the values. So every time we can throw away 1/4 of the values. So this is a t 3/4 of the values. Okay. And this is a very good guarantee. And for this part, we also have to do a recursion to get the median of the median. And after that, we have to do a theta n, and the theta n is kind of a similar process to the partition. So putting all this together, and we are able to prove that for this Tn, it is smaller or equal to the Cn. So this is guaranteed to be a linear time partition algorithm. So you know now there is a worst case linear time selection algorithm possible. Okay, using this algorithm, we can really do a lot of the cool things. And for example, using this linear time median algorithm, and we can do the ith order statistics. Okay, so we want to first find the median, and then after we have the median, we want to do a partition. So when we do the partition using the median, we are doing the 50 to 50 partition. That's guaranteed because that is the definition of the median, right? And then after we have the 50 to 50 partition, and then depending on the ith order statistics, the I value we are looking for, we only have to do the search in either the lower half or the upper half. So in this case, we can just simply do the recursive calls, and then we are able to find the ith order statistics or the ith smallest value in this array without sorting all the values. And this will be an ON algorithm. Okay, so let me repeat the question, what we have again. So we started from a worst case linear time median algorithm. And then using this algorithm, we are able to do a linear time selection algorithm. You give me any I value, I will tell you what is the ith order statistics or what is the ith smallest value in this list you are looking for. And I can do that in linear time. Okay, so the next question. Well, again, we start from the linear time median algorithm. If we have a linear time median algorithm, and then if we plug in this algorithm to the pivot selection part, now we are able to get a perfect pivot. Why? Because using the median as a pivot, we are able to do a perfect 50% to 50% partition. So in this case, the quicksort will be Tn equals 2n divided by 2 and then plus AO. AON. So this will be a O n log n guaranteed. So if we have since we have such an algorithm, this means for the quicksort we don't really have to worry about the worst case because we are able to do a perfect partition. Okay. And then, well, at the very end, I challenge you how do you get the middle five values. And you can either do a recursive way, that is you get the median and then you take the value out, and then you just recursively do this or iteratively do this median for 5 times, and then you will have the middle 5 values. Okay, this is one idea. The other idea is you get the median and then you just do a partition. When you do the partition, you have the lower half and the upper half. And for the lower half, you want to get the max and the second max. Okay, for the upper half, you want to get the mean and the second mean, and putting those 4 values and the pivot together, and then those are the middle 5 values. Okay, so either way, you can do that in linear time. So that's also guaranteed. Okay, so well, those are all the topics we want to cover about the sorting and order statistics. Now we really want to move ahead and we want to talk some data structures. And as we are talking about data structures, we will also talk about those algorithms we can implement using those data structures. Okay, so this is the end of this video, and well, we review the order statistics and some of the cool ideas we can do using the linear time order selection algorithm. And now we want to move on. In the next lecture, we will start to talk about the binary search trees